Hi all, this is Alan with Bothell STEM Coach, and today we are going to continue on with the AP Calculus 2004 free response questions, and we're looking at number 5 here. So the graph of the function f is shown above, consists of a semicircle here and 3 line segments. Let g be the function given by this. Find g of 0 and g prime of 0. Okay, g of 0 we just do by definition. It's the integral from -3 to 0 of f of t dt. That's the area under the f curve, under the curve f, from -3 to 0. So -3, that's here, to 0. I need to know this area. This is the area of a trapezoid, or you could break it up into a triangle and a rectangle if you're not good with the trapezoid. But I'll do trapezoid. You average the two bases, which is, this is a height 2, this is at 1, so 2 plus 1, and then times the height here, which is this distance. 3. So that's 3 times 3, it's 9 over 2. Okay? G prime of 0 is equal to the integral, to find g prime of x, when I take is just the derivative of this, by fundamental theorem of calculus, this is just simply equal to f of x. So g prime of 3 is equal to f of 3. And the function value at 3 is 0. So g prime of 3 is equal to 0. Okay. Find all the values x in the open interval -5 to 4, which g attains a relative maximum. Justify your answer. So what does it mean for g to have a relative maximum? Well, g prime of x needs to equal 0 or undefined. We already demonstrated that g prime of x is equal to f of x. So that's the same as saying, this statement is the same as saying f of x has to be 0. When is f of x 0? Here, here, and here. So these are the critical numbers. The critical numbers are x equals -5, 1, and 3, right? Now, a relative maximum occurs when g prime to the left. So remember, what we need to do is we need to construct a table of intervals, right? Oops. Let me make a little more space. I need to do them in order. It's -5, then 1, then 3, then g prime of x, which is equal to f of x. And then I need, let's see, less than -5. I basically need to look at the intervals in between, right? Because I know all across here that the derivatives were definitely 0. And I'm looking for a sign change. And in particular for maximum, I'm looking for when the curve goes from positive derivatives to negative derivatives, positive to negative. So positive to negative would only occur like on this interval, because you see, like here f of x is 0, here f of x is greater than 0, and it's less than 0. So like in this region, it's positive between 3. Actually, it's positive here, and between 1 and -5, it's also positive, and then less than -5, it's negative, and then greater than 3, it's negative. So you see, we only go from positive to negative at x equals 3. Okay, find the absolute minimum value of g in the closed interval -5 to 4. So to find the absolute minimum, first I have candidates. I need to look at the relative minimums. The relative minimums are when the sign changes from negative. So this is a relative minimum. Oh, that's not -5. This is -4. I don't know what I'm thinking. I was reading this, but this is -4 is a relative minimum. But I also got to check when I do absolute value, minimums or whatever, I need to check the endpoint. So I need to check x equals -5 and x equals 4. And then at that point, I'm just creating a table. I just need to compute what g of -4 is, what g of negative 5 is and what g of 4 is. And I just need to compare which one is the biggest. Or smallest, sorry. So let's just go one at a time. G of negative 4, by definition, is the integral from negative 3 to negative 4 of f of t dt. Now, it's normally the area from negative 3 to negative 4. That would be this area, this triangle. But that would be if I was going from negative 4 to negative 3, left to right. Okay, that would make this positive area. So this area needs to be negative because I'm going right to left. So this area is equal to negative. Let's see, the 1/2, the base is 1, and the height is 2. So it's a triangle, right? So it's negative 1. And then g of negative 5 is the integral from negative 3 to negative 5 f of t dt. That's equal to the area of this triangle negative plus the area of this triangle. Actually, these two triangles cancel each other out because that whole area from negative 3 to negative 5 is just going to be 0. And then g of 4 is equal to the integral from negative 3 to 4 of f of t dt. So that's the area of under f from negative 3 all the way to 4, which is here, all of this area. This area is going to be positive, by the way. I'm actually not going to calculate it. I just know it's going to be greater than 0. So this is the smallest one. So the absolute minimum value is negative 1. Because this is going to be greater than 0 because the area is positive. Okay. And then D, this is kind of a long question. Find all the values of x in the open interval negative 5 to 4 at which the graph G has a point of inflection. Point of inflection is when the second derivative is equal to 0 and it changes signs. So we know that g prime of x is equal to f of x. So we know g double prime of x is equal to f prime of x. So I'm looking at I want to look for when the f prime of x is equal to 0. That's the slopes. So you could do 0 or undefined. I think 0 or undefined is technically the so that happens here, right? Because this slope doesn't exist at x equals negative 3. Slopes here, 0, no slope there. Here the slope is 0 at x equals 1. And then here I have no slopes from at x equals 2. Okay, so those are my 4 candidate points for points of inflection. Now, points of inflection mean the second derivative have to change signs, or that means the first derivative of f has to change signs for the second derivative to change signs. So I look at the negative 3, and I look to the left, and I look to the right, and f prime changes signs. It goes from positive to negative. So this is a point of inflection because the first derivative changes signs, which is really the second derivative of g. So you got to kind of keep that in your head. At this point at 0, the slopes are negative and stay negative, so that is not a point of inflection. Here, the slopes go from negative to positive, so that is a point of inflection. And at 2, it goes from that to that, so the slopes do change signs. So x equals negative 3, 1, and 2 are points of inflection. All right, and let's take a look at the solutions. 9/2 and f of 0. I don't know why I plugged in 3. 0. It should have been 0. I would have gotten 1. Okay, so I got this part wrong because I plugged in 3 instead of 0 for some reason. I don't know why. My brain was clearly not working. Relative max at x equals 3. Is that what I said? B, x equals 3. Yep. C, I got negative 1. So the absolute value is negative 1. They checked all the candidates. And then negative 3, 1, and 2. Negative 3, 1, and 2. Okay. Hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.